We're going to talk about the free response question on A. The directions say picture to the right is the graph of a polynomial function g of x and use the graph to answer the question. So on A it says identify the zeros and then their multiplicities and then explain specifically how you know the multiplicity of each zero. So we need to get better at our academic vocabulary. So no chill, no bounce, and stuff like that. So let's try to learn the correct way to explain something in mathematical terms. So we can definitely see a lot of you guys were able to identify the zeros of the function. And we know that -3 is a multiplicity of 3, not because of the chill, but because the graph crosses the x-axis and it changes concavity. All right, and then that's what gives us that different type of shape right there. And then x equals 2 has a multiplicity of 2, not because of the bounce, but because the graph is tangent to the x-axis, which means it's only touching once at that spot. All right, now on B, it says, will the leading coefficient of the equation be positive or negative? So not only do you have to say that, but you have to give a reason based on the end behaviors and the degree. So your answers need to have those conditions in them. So, and we don't want to, I gave you guys credit if you said like falling to the right, but that's not what we want to be able to say. We want to be able to look and use the notation to justify our mathematical responses. So the leading coefficient is negative because the degree is odd. You already know that it's negative because it's falling, but we're not going to use the word falling. So the leading coefficient of negative is because the degree is odd. Okay, it's opposite, right? So the degree is odd, and as x approaches negative infinity, in other words, you're describing the end behavior on the left. As x approaches negative infinity, g of x is approaching infinity. And as x approaches infinity, which is down here, g of x is approaching negative infinity. And this is the proper notation to indicate like falling. Okay, so we want to be able to utilize that mathematical language. All right, then it says on C, it says identify x coordinates of the points of inflection and give a reason for each of your answers. So some of you gave me ordered pairs. Well, I only want the x coordinates. So let's take a look at our x coordinates. So, well, the first one is x is equal to -3. And the reason that's a point of inflection is it's because it's a 0 with multiplicity of 3. All right, so we've already established that it was a multiplicity of 3 up in A because it changes concavity. So when you are justifying this, we know that -3 is a point of inflection because it's a 0 with multiplicity of 3. The next one is going to be, according to the conditions, if you have a 0 with multiplicity of 3 and either a max or a min immediately following that, the approximate point of inflection is going to be based on the midpoint. So -1.5 because it's the midpoint, and again, only the x coordinate. -1.5 because it's the midpoint of a 0 with a multiplicity of 3 and a minimum. Okay. Then the last condition says, hey, the other point of inflection is when you have a minimum and a maximum consecutively, then the point of inflection is right there in the middle. So we took the x values. So you're adding up the x values and dividing it by 2. So x equals 1 because it is the midpoint of the max and the min. All right, now let's do D. It says identify each of the following intervals. On your test, I only asked you where it was concave down. And so when it's concave down, you need to look at this component of concave down. There's two types. This is concave down, but increasing. And then this one is concave down but decreasing. So if it looks like any type of this type of curve, then it's going to be concave down. So let's take a look. From here to here, this is concave up. Okay, concave up. It looks like the up part of a cup. remember that at the multiplicity at 3, it changes concavity, okay? Remember, but only to the halfway point. So this part right here is going to be concave down. And again, it's going to change concavity because we said that that was the inflection point. And then we've got here is the other inflection point. So it's important to notice where your inflection points are. Here, here, and here. So that means we've got to be able to identify where there's a change in concavity. So that means here to here. All right, so at each of those points where those black lines are, you're changing colors of concavity. The green represents concave up, okay, and the purple represents concave down. So we are going to be from, and again, this is never brackets, it's going to be from -3 to what we said the x value was -1.5. So on that interval, and then from the interval from 1 to infinity, okay? And so let's just put that up here. We have from -3 to -1.5, and then from 1 to infinity.